Welcome to our continuing series on non-parametric statistics. Today, we shall learn one of the most widely used statistical tests in research, the chi-square test of independence. Although it is a non-parametric test, it is used in thousands of research papers every year because it helps us to determine whether two categorical variables are associated. Before selecting any statistical test, always ask one question: what is my research objective? If your objective is to compare groups, you will use tests such as t-test, ANOVA, Mann-Whitney, or Kruskal-Wallis. If your objective is to study relationship between numerical variables, you will use Pearson's Spearman or Kendall correlation. However, when both variables are categorical, the approximate choice is the chi-square test of independence. This decision tree will help you choose the correct statistical technique throughout your research. This is perhaps the most important concept in today's lecture. Correlation and association are not the same. Correlation is used when both variables are numerical. For example, study hours and examination marks, age and annual income. Association, on the other hand, is used when variables are categorical. Examples include gender and product preference, education level and employment status, residence and voting preference. The chi-square test measures association, not correlation. Suppose a company wants to know whether product preference depends upon gender. Both variables are categorical. This is a perfect application of the chi-square test of independence. What are the hypotheses? Notice that hypotheses are different from correlation tests. The null hypothesis states that variables are independent. The alternate hypothesis states that an association exists. See, observed frequencies are the frequencies which we observe, but the expected frequencies may be equal or better if we use the formula row total into column total divided by grand total. Chi-square calculation shows one cell calculation. For instance, observed value is 30, expected value is 22.5. Now, in our case, observed frequencies are male, female, product A, product B, 30, 20, total 50, female 15, 35, total is 50. And on column side, the totals are 45 and 55. Total, grand total is 100. So, expected frequencies, gender, product A, product B, male, product A, 50 into 45 divided by 100. For males, product B, 50 into 55 divided by 100. Female, 50 into 45 divided by 100. And product B, 50 into 55 divided by 100. Chi-square formula is sigma O minus E whole square divided by E. O means observed values, E means expected values. So O minus E whole square divided by E. So now do one cell manually. Chi-square is sum of all contributions. So chi-square statistics has been calculated as shown earlier slide. So large chi-square means greater evidence of association. SPSS practical, we take the data, analyze, descriptive statistics, cross tabs, statistics. SPSS output gives us Pearson's chi-square and p-value. Let us do it in SPSS.
See, there are two ways to enter data in SPSS. You can write down gender and preference, say male, preference A, male, A, preference A, male, preference B, female, preference A, female, preference B. Like this, you can make 100 entries. Or you can calculate the frequencies and then write down the frequencies here. Male, preference A, 30 frequency, male B, 20 frequency, female A, 15, and female B, 35. So there are 100. Total is 100. But when you write the data like this, you will have to do one thing. You will have to tell SPSS that we are using frequencies. So go to data. Down there is a weight cases. Just click on that weight cases, and in that weight cases, these weight cases by do not weight cases or weight cases by frequency. So you will have to select this weight cases and then you will have to select the frequencies. This will be okay. So this will automatically give the weightage as per the frequencies. Say okay, the output will be shown in a separate this thing weight by frequency. Now we'll close it. We will not save it. And then we come to analyze, descriptive statistics, and then we come to cross tabs. Descriptive statistics, cross tabs. In the cross tabs, rows are our gender and columns are our frequencies. Okay, and we'll go to statistics. And on the statistics, we will click on chi-square. We will not click on anything, correlation, contingency, and all other things. So we'll say continue. And we will say okay. Now in the okay, so it is coming as frequencies already shown. Female A 15, B 35, male 30, 20, and total 50, 50, 100. So now the Pearson's chi-square is 9.091, but continuity computed only for 2 into 2 table. This will be okay, 7.919, and with the significance value as 0.005, it is less than 0.05. It means there is an association between male and female and preferences A and B. As you observe this data, you can easily see so female there are 35 which they prefer B, and the male there are 30 prefer A. So the same thing is shown here, that the analysis says that there is a association.
Python practical, we use pandas and SciPy stats chi-square contingency. We say imports pandas as PD from SciPy.stats import chi-square _ contingency. Now table is 30, 20, 15, 35. So we say chi square, actually it is T2, chi 2, P, comma, DOF, comma, expected. So this will give us the chi-square contingency table. Print chi-square, that is chi2, print p-value, comma p, and print expected frequencies, and then print expected.
Let us now work on Python. I have already started the editor Jupyter and pasted the commands as you have seen it in the PPT slides. We are going to import pandas as PD from SciPy stats, SciPy.stats. We are going to import chi2 contingency. So these are the things you should know. And our table is within square brackets 30, 20, 15, 35. Just see that square brackets, two square brackets for every array 30, 20, 15, 35. We have put it into the square brackets. Now we are going to find out chi-square. So chi-square P, DOF and expected values, and chi-square contingency table, print chi-square, print p-value as p. Now if you want to round off these things, you can put a round up to 2 decimal or 3 decimal. We'll do it after this. Print expected frequencies and all. Now when we run this, it will take some time to import pandas and import chi-square contingency. Let us see now. It's going to take some time. Now, this is chi-square is 7.919. It is up to so many decimals. I will try to round it up to 3 decimals. P-value is 0.0048, and we were getting the same thing in our SPSS. Expected frequencies are 22.5, 27.5, 22.5, 27.5. It calculates with the formula a row total into column total divided by grand total. This has been calculated by this method. It automatically calculates. Now let us round it up around open bracket, then chi-square what you have written up to 3 decimals, and you will have to close the bracket here again. Let us see this now. Round p-value also, comma, open bracket, and up to 3 decimals. Okay, and then we will close the bracket again. We have started 2 brackets and we have closed the 2 brackets. So round, now this bracket, first bracket is around p. This was the first bracket which we closed, and the second bracket is closed with this. Okay, now expected frequencies and all, it will be okay. So now let us run it again. Run. Now it is automatically 7.919. P-value is 0.005. Expected frequencies are 22.5, 27.5, 22.5, 27.5. You need to write, you want to write, you write it, otherwise it's up to you. Now, we will also discuss how to report this in our research article.
Python, both produce same chi-square, same p-value, minor rounding differences may occur. How we report in the thesis. The chi-square test of independence and showed a significant association between gender and product preferences. That is, chi-square is 6.70, p-value is 0.009. See, when we have taken up the equal frequencies, there was no association. But when we have taken up when we have taken up the prorata, that is row total into column total divided by grand total frequencies, then it came out to be statistically significant. One characteristics of good research is that they do not simply state whether a result is significant, they report the complete statistical result. This includes the chi-square statistics, degree of freedom, p-value, and an appropriate measure of effect size. Such reporting provides readers with both statistical significance and the practical importance of the findings. Common mistakes. Using percentages instead of frequencies. Small expected frequencies using chi-square with numerical values. Ignoring effect size. Now let us see the decision tree again. Summary is numerical values we get numerical and numerical values we get Pearson. If they are ordinal, we use Spearman. If ranks with many ties, we use Kendall. If there is categorical and categorical, we use chi-square. Researcher's Corner. Before we conclude, let me share a few important points from the researcher's perspective. The chi-square test tells us whether two categorical variables are associated. However, it does not establish a cause and effect relationship. A statistical significant result simply indicates that the variables are related more than would be expected by chance. Before interpreting the results, always check the expected frequencies. If too many expected counts are small, the assumptions of chi-square test may not be satisfied. In a 2 into 2 contingency table with small expected frequencies, Fisher's exact test is usually a better choice. Finally, remember that statistical significance is only part of the story. You should also report an effect size such as phi or Kramer's V to describe the strength of the association. This is considered good research practice in thesis and journal publications. Thank you. Please subscribe, share, comment. Our next video is chi-square goodness of fit test. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.